Today we are doing lesson 7. This is the last lesson in the unit. So we are going to be doing a little bit more with exponent laws and how that works when we're dealing with fractions or what we call quotients. So the base of a power might also be a quotient. So for example, 5 over 6 is a quotient and it's raised to the power of 3. So what that means in repeated multiplication is that 5 over 6 is equal to the power of 3 is equal to 5 over 6 times 5 over 6 times 5 over 6. Now we can simplify that without actually multiplying it all out by raising our top number to the power of 3 and our bottom number to the power of 3. So 5 over 6 becomes to the power of 3 becomes 5 to the power of 3 over 6 to the power of 3. So the 3 can come in for the exponent as long as you bring it in for the top and the bottom of the fraction. So that brings us to our exponent law for a power of a quotient. Okay, here it is. A to the power of B, or sorry, A over B to the power of n is equal to A to the power of n over B to the power of n. So this works with integers, this works with variables, it'll work with anything we want it to. So let's give it a try. Here we have a fraction as a base, all raised to the power of 2. So 2 over 3 all to the power of 2 becomes 2 to the power of 2 over 3 to the power of 2. Now depending on what the question asked, it might want you to go a step further than that and write 4 over 9. Next one, 4 over 5 to the power of 3 becomes 4 to the power of 3 over 5 to the power of 3. Last one, now we have a negative sign we need to take into account. Negative 3 stays in brackets because the 2 is outside of the big set of brackets, and 2 to the power of 2. So my answer here would be negative 3 times negative 3, which is positive 9 over 4. All right, let's try it with variables. With variables and a combination of coefficients and variables. So a over b to the power of 2 means a squared over b squared. Now we already have exponents on my quotient. So a already has a power of 3 and b already has a power of 2. So now we're going to use power law, which says that we multiply our exponent. So it becomes a to the power of 6 over b to the power of 4. And just when you thought things couldn't get more complicated, we need to throw in more variables and more coefficients. So biggest mistake that I see is forgetting to apply the coefficient and the exponent. So we just leave it as 2 over 3 and we forget that we need to square it. So it becomes 2 squared x to the power of 4, y to the power of 6, and 3 squared times c to the power of 8, d to the power of 2, remember the invisible 1, and e to the power of 16. Okay, so that's as complicated as it will get. I know I went a little fast, so if you're having trouble with the power quotient law, make sure you let me know. So now we're going to try mixing it all together, putting all of the exponent laws we have learned together. So just a recap of our exponent laws. We have product law, quotient law, zero exponent law, and then we have power of a power law for both products and quotients. Okay, so let's use the exponent laws and order of operations for the following questions. Excuse me. Okay, sorry about that. So we need to do inside brackets first. So this becomes 3 to the power of 5 because we're multiplying something with the same base. So we add the exponents. The next one, I'm going to do it at the same time, becomes 4 to the power of 5. And the 2 remains on the outside. Now I can use exponent laws, a power of a power, which says that if I have a power and a power beside each other, I multiply them together. All right, those are really big numbers, so you have to use your calculator to figure it out. We'll just leave it as it is right now. All right, next one, 6 times 7 to the power of 2 plus 3 to the power of 8 divided by 3 to the 6, all to the power of 3. So I'm going to start by doing inside my brackets. 6 times 7 is 42. Okay, next one, I have the bases are the same and they're dividing, so I'm going to subtract the exponents, leave the power of 3 outside. Okay, 42 to the power of 2, I'm just going to leave that. And I'm going to use my power of a power law, 3 to the power of 6. So these are really big numbers, but I could square 42 by multiplying 42 by 2 and raise 3 to the power of 6. But for now, you can just leave it like that because I don't want you to focus on using your calculator. All right, next one. So for an example like this, I would think about using BEDMAS. However, I noticed right away that I'm going to do inside the brackets and then I'm going to take whatever's inside the brackets and raise it to the power of 0. But I know a trick, and that's that anything to the power of 0 is equal to 1. So it doesn't even matter what's inside my brackets, I will still get the answer of 1 because I'm raising it to the power of 0.